my awesome HTML skills. So I have no slides. This is actually going to be doing a live demo with all the risks of a live demo. So hi, my name is JC. I've been at Google for 4.5 years, and I was in Strasbourg, France for university. And then I worked on the GCC compiler in a startup, and then worked on Android compiler for a few years in Intel. And then I joined the Java profiling team inside of Google, and I supported what's called the Java agent, which we'll be talking about in a bit, and especially working on the heap profiler for JDK11 and getting that open source for JDK11. And now, like was said, I'm in Atlanta in my basement, working on code health for Google and automatic changes, to have changes that are automatically generated, tested, reviewed, and that we can get our repo moving forward and maintained. So all this to be said is that I work very under the hood, and you all probably know GCP more than I do. You definitely probably know more of front end than I do. So if you start asking questions about that, I might have questions for you. A tiny bit, and this will be the last text that I show you from a fake slide point of view, is that it's a live demo. Anything can go wrong. I tested it a bit, seems to work. I'll be running Java 11 and I'll show you why, but mostly it's so that I can show what the Java heap profile I can do in GCP. And I will show what's called the continuous profiler, which basically collects what your job does from a CPU point of view and a heap point of view. And the demo code is really simplistic, really not front-endy at all, not how we would normally do a server or job or service, but it just is there to showcase the profiler. This is a live demo, anything can go wrong. But if you ask anything, let me know. If there's any issues you cannot see what I'm saying, let me know. And please ask me questions. Don't make this me talking alone, because then I will become bored, and you would be bored too. Preamble, I have a 5-year-old and a 3-year-old who are home due to a runny nose. So if someone starts jumping in or running in, you might see a child during this presentation. That's about it. So from a what is the continuous profiler? Basically, if we look at here, if you want to profile your Java job, and this is, like I said, the last thing I want to show because it's open and on cloud, profiling Java applications, you can actually show CPU time, heap, and what's called wall time. So if you had a job, a cool job that is very aptly named Java profiler testing, you could have something like this, where, for example, you have your CPU time, your wall time, and your heap. And so in this case, for example, you could show that your job, if I go here and click on now and say, well, in the last like 10 minutes, what has happened? And I can see that my job is, for a Java job, quite surprising, because it's spending its time in the libc, in the libjvm, a lot of random things here, unknown Java frame and libthread, which for a Java job is not good. We would not automatically be wanting to spend this much time here. LibJVM, for those who don't know, is the library that actually is the JVM underneath the hood. And so it is anything that is the runtime itself, including the compiler. So your just-in-time compiler that happens to be in Java, well, happens to work for Java codes, and the garbage collector. If we go here, what you would not see is we have thread run, which is actually our Java threads that I am running right now. And because I wanted to have fun, I am actually going to be running a pi calculator, because, you know, March 14th is coming soon. And so basically, if I look at my job now and go to this awesome like thing, I can look at my job and say, well, I have this job that's running. It's got awesome HTML, and I'm running 15 threads that is calculating pi. And I'm at iteration, 1 million, because I let this run a little bit before starting this talk. And I'm calculating 684, pi's per second. And, just to ensure that my code was actually right, because believe it or not, the first iteration of this code, it was wrong. I show that pi is calculated relatively correctly, right? And so now if I come to my profiler and go, it seems I'm spending a little bit of time in calculate pi, but that's about it. I could go and look at my code. And so if I were to want to look at my code and I wanted to see what it's doing, and if I remember how this works, let me close this up a little bit. Let me just open correctly the right things. Here we go. I would look at this and say, oh, here is my code. So my code actually is embedded into a lot of random folders because what I did was I went on Google, GitHub, and downloaded all their sample examples. And I took the App Engine JDK Java 11, and then I looked at all of these and went, hello servlet looks like a cool name as a start. And I'll just start with this one. And I opened it up and I said, oh, there's a hello world application, which I aptly renamed Ask the Expert. And if I go down here, and I'll go over this in a second of the code that I have, what we really have is our calculate pi, which is the one that my job is saying that it's spending its time on. And I'll look at it and go, oh, okay, this is just calculating pi. And if I go back to my profiler, I'll say, oh, it's calling Fred run calculate pi. And if I want to start looking at things, I'll go, where's run? Run is down here. And this is where I call calculate pi, right? And I can go, well, if I wanted to try to optimize this, I probably could do something about it. And so let's see what we can do. Now, the interesting things, again, about this profiler is that it's continuous, which means that it always runs. You can actually tell it the different versions that you would want to do, and I'll show you how you do that because we're going to change the code in a bit. And you can also show your heap, for example, and you can show and say, oh, well, if I look at what my code is actually doing, well, I am actually in PyCalculator run, I'm allocating something and just keep something, right? And I can go, oh, I'm actually allocating 13 megs. Again, this is a demo code, so I didn't go crazy about it. The other things that are interesting is that you can click on different frames and you can start seeing what they look like. You can go down the hood and look really into the inits. You can come back if you click back up here. And there are various things that you can do where you can compare the versions between themselves. You can give a start time and end time. You could see how your job is doing across the board. And at this moment, because I talk a lot, I will drink my tea and say, are there any general questions? Because first question is always hard, but if there are questions in QA or whatnot, I will pause and try to answer them correctly. And drink tea.
Hello, G. I have a question, and I will be your host to ask the question to our experts tonight.
I'm less lonely.
Yeah, and my first question is: you talked about JVM 11, and I know with Java we can write in different language. I mean, with Scala, with Kotlin, with Groovy, with many things. Is this kind of profiler also work with any language? If it's the JVM that run this language at the end?
Yep. As long as the JVM, as long as it's running on the Java 11. So as long as it's running in Java 8 and above, you would have the CPU profiler always there. So the CPU and the wall time one will always be there. The difference between CPU and wall time is the CPU cycles on active threads and picks up profiles, whereas the wall time says to all threads, give me a profile every so often. And so in the wall time one, if I click on it, and I can do that now, you'll see that it's telling me, you're spending a lot of time in GC. That's what you're doing right now, right? Whereas you get that hidden if you use CPU. The heap profiler is only for Java 11 and onwards because it wasn't available there. I actually, we used to have a version internally at Google that did it for Java 8, and I worked on open sourcing it for Java 11. So any technology that is running on Java and the JVM from Java 11, you can get the heap profiles and you can get the stack traces from it.
Okay, thank you.
All right. Any other questions? Yeah. Should I move on?
Yeah, you can move on.
All right. So the one thing, let's say, so for my awesome demo, my epic code that's complicated, and I know that normally we would have requests and whatnot, but I was trying to make it simple, is really, I could actually, instead of calculating every, so I'm just gonna go 2 seconds to show the code here and say, oh, well, calculate pi, calculates iteration, but really it's always doing the same calculation. And so often, when we're doing this kind of work, we will go, well, if the input is the same and the output is the same, let's just throw up a cache on it and just have the input output. And I'm pretty sure I'm not teaching anybody that. So let's imagine that we do that and we just say, okay, let's just do something that does a simple calculator for this and says, I'm going to actually do a cache version of this, right? So I'll do cached, get pi, and then I'll do int iterations. And I'm doing this, like this by hand because, I felt that if I write code, I feel less lonely. And then basically, let's imagine that we add a hash map up here. And for what it's worth, if anybody is like me and under the hood, I normally work in VI and I never use an ID. This is to say at what point I am outside of my shell, like safe zone. That being said, let's imagine that we do this and we have like our nice little hash map here. We call it aptly cache. And then we just say, well, I have a hash map and I'll just create it directly here and call it a day. And then here, what I'll do is I'll just say, well, okay, if I actually have my, if I already have calculated it, then I'm just going to return it. And then I'll do cache get iterations. And if I have not, then I actually do have to go calculate it. So then I'll just say result, I'll say calculate pi, I'll go iterations, right? And then I'll say, well, let me send it into the cache just so that I can remember it. And here we go. Whoops. And then here we do return result. And I'll be all happy because I've done this and this looked cool and that was fun to write up in front of everybody. And hopefully there's no, problems here. And so then I'll just say, well, here I will do cached get pi. And what I'll do is I will go back here and say, open my terminal here. And again, because this is the way I learned how to do this last week, I will install it and it'll say, I'm not happy because I'm not in the right folder. And so I'll just go into the right folder that I want. I'll say, please mvm install it. And then I will say, well, actually, I would like to change the version so that I can compare what's going on between versions and ensure where I go. So I'll go into my Palm XML and I'll go here somewhere down where I have an awesomely named Ask the Expert version and say, let me up the version to 43, right? It's no longer the meaning of life, but it's the meaning of profiling. And so at that point, I'll come back here. I'll say install. It tells me it's got a compilation problem at line 111. And so I will just go fix whatever I did wrong, which is, let me look, 117. Here, I have forgotten something. What are you mad at me about? Here, and then just install, right? And again, there are most likely very good ways of doing this. This is the way I learned and taught myself how to do this last week or 2 weeks ago when I was starting to prepare this nice little demo to explain the profiler. And so then I'll deploy it and the deploying will say, yay, it worked, we're all happy, and the job will start again, right? And so during this time, I can talk a little bit more about the profiling. So we really actually want to show what's happening under the hood for your program. And the idea is to have this always continuously, at least in our sense, it's often we have profiling working on all of our jobs at any time so that you can actually get these profiles on the fly. So they're very low overhead style profiling. We call it continuous profiling, like I said, because it always works across the board. And we generally provide this information to anybody who wants to see like what their job is doing. And so the CPU, the heap, and the profiling. It also helps people on a CPU point of view. Inside of Google, we can look at all the biggest libraries that are being used across Java. There's also the use cases of seeing like, because we know where you're spending your time in libraries, we know which libraries to actually optimize. And so you know who you can actually help out across the board. So that being said, if we look at this, we go, okay, I launched my job. If I come back to my awesome epic job here, if I try to update the screen, it should yell at me and say, well, there's no calculators because I don't start the threads yet until I am ready. So I tell it, okay, please, could you please start my threads? And at this point, it'll say, yay, all the threads have started, and it'll start calculating. And at some point it will, though it's a live demo, it'll tell us, okay, well, we're running, but we're running at the same speed. My cache has actually changed absolutely nothing in performance. And this is where you go, huh, I was convinced that this would work. Why does it not? And of course, if we think about caches in general, it is a question of like, how often do you get the input right compared to the output, and how often do you re-get the same inputs? Turns out, because this is a demo, I cheated the system, and I just said that my I would have 10,000 values that were randomly chosen by an epic random generator, and just go ahead, right? And so normally you would actually imagine that it would at some point hit correctly and we'd be able to be flying through these results, but we're not. And so if I come back to my awesome profiler, the interesting part is that if I go back to here, and if I start, like, I have to wait a little bit for the system to come up. Again, normally you would do this on servers that stay on for a while. And so you get these profiles there. At some point you get the version number 43, which is the one we got. And you notice that, oh, I am still spending quite a bit of time just in libjvm. I'm spending a lot of time in libc and libthread, and really still not that much time in calculate-py. And this is where I come back and go, okay, I tried to solve this problem, tried to make it faster, didn't work. I'll go to the heap and I'll look at what's going on. I'll wait a little bit and see. And it actually tells you, if you look at it a little bit, it'll tell you how many profiles it got. If you look at a longer running version, so for example, my version 42, you'll see that I've got more profiles here. You can actually show the top 1% of like size and allocations. If I maximize my screen, I think it looks horrible for you. At least that's what I've been told. Things look really small and then you can't read. So that's why I make it smaller like this, if that makes sense. Let me know if you want me to change it somehow. And so basically, yeah, so really what we try to do is we say, okay, let it run a little bit, give us these profiles, and at some point we go, oh, I've got this integer value cache, so my cache is working as expected. It's getting full, but I've got this just to keep something that's actually allocating also quite a bit, and that's interesting. And if I go look again, like I said, at the wall, I'll notice that GC is also active and doing quite a lot of work. And so I come back to my heap and go, I wonder what this is, just to keep something, aptly named method for a demo. Any questions at this point that you would like to ask? And while, again, I sip my tea.
Yeah, yeah, there is a question from the attendees. Question from Fabien that asks, there is some tools in Profiler to help to optimize your code, the code problem or something like this.
So this is a low level, I'll say it's a low level profile. I'm not sure I'm going to answer the question correctly, but maybe Fabian can like expand on it. It's a low level profile that tells you where you're spending your time and where you're allocating. It doesn't make automatically decisions for you and whatnot. There are some that exist, but I think an automatic optimizing system is hard to do in the general case. My demo here is easy enough that it's easy to show what's going on and whatnot. But when we work on actual services and servers, the problem space is a little bit more tricky. It's good to know where you're spending your time, but then how to optimize it, you always have different opportunities and solutions. So I don't know of any great magical key optimizer that will just work generally. Often you need good profiling tools that tell you where to look and where are the problems, and then start tweaking and tuning and optimizing your code. Again, this is JC's opinion, right? Trial and error. Yep, that is generally what I do, and that's me. But yes, right. I will be open to saying, let's try to work on an automatic optimizing system, but that problem space is hard.
And just a final word about this, if there is a software engineer, it's because there is problem to solve. If you have automatic solution, no software engineer.
Right. Yeah, that's very true. We've noticed that like often what happens in jobs, like what I've seen happen is often in you have multiple spaces, right? Which is like this simple demo where you have like, oh, I could put a cache, or oh, you're gonna see in a second, oh, we're allocating all the time. Let's not allocate all the time and stuff like that. And at some point you've solved your code to a good point where the code is right, but then you have to start tweaking your JDK and JVM flags to get it running at the right moment to reduce the number of GCs happening and whatnot. And that is even yet a different space that you have to run into in Java jobs. It is something that our software engineers under Java do really well and know what they're doing. I know how profilers work, so I know how to give them the data that they can use. Right? Does that answer your question, Fabien? I mean, I suppose via Guillaume, but
yeah, I hope. Yeah. There is another question about Andres. Can we use profiler only with Google App Engine standard? Can we use it elsewhere?
So, believe it or not, good segue. Then I will pause on my conversation optimizing and just go into here on the official Cloud Google Profiler Docs Profiling Java. There's a perfect example of how this is done. It tells you where to how to enable it via the Cloud Console, and it shows you installing the agent via Compute Engine, JKey, Flexible, Standard, and outside. So it's available in various shapes and forms depending on what you're using. It's not only on Standard and App Engine. It just turns out what I used for my demo. Okay.
Okay. Thank you.
For what it's worth, and I wanted to show this, and I can just look do you see this one that I've added? Yeah. So all this code that the agent, so let me start over. Java sits, 10,000 kilometers in stratosphere, and under Java is the JDK and the JVM that run in C++ currently and run the runtime of Java. Next to it is what we call the Java agent. And the Java agent is like this side little toolkit that you can use to understand and peruse what your Java job is doing. And this agent often is used for profiling systems and whatnot. It is built, I say whatnot a lot in this presentation, I'm sorry, today, apparently. It's a Monday thing. And often this is built over JNI and Jvmti, right? And I can go into depths of Jvmti, but I think that's out of scope for here. What's important to note is that the whole cloud profiler agent that we are talking about and that provides these profiles is open source, and you can actually go see it. And you can see the code that we have, and you can build it yourself. And then you basically just add it to your job. If I come back and I can remember where, like I can not remember where, but remember where this tab is, you actually just call it like this. You say Java, that's how I want my entry point, and I want to call it with agent path. And it turns out that on this instance, VM instance, I installed this .so here on /opt/prof. And I said, in this case, here's a flag, which is enabled heap sampling, right? And so you can actually do this for any job. The only difference is that the cloud agent that we use talks to our whole cloud infrastructure, so it might not work outside the box. But the idea of adding an agent and profiling your code is something that is not only available like here. There you can actually look at this code, you can hack it. You can look at, there are other profiles called async profiler. There's another Java agent called YourKit, and there are various other options that will do very similar kind of ideas, which is use the JNI and use the Jvmti infrastructures to build up some sort of information gathering that they will surface up to your Java job. Okay, that was just my segue. Okay. So I'm trying to find my, technically there's no output of this Java agent because it's basically funneling files and information back to cloud servers and the continuous profiler to be able to show you this. But theoretically, you're in C++ land, so you can go do whatever you want with these outputs and profiles. In like what we have done in the past is, so if you look at, for example, so I'm clicking around because I want to find where I want to do. What we have done in the past, for example, is if you have a handler here that says do get, and then at some point you say go query, and you said, for example, give me the CPU profile, you could then go down to your agent and say, give me the current CPU profile, and the JNI code could give it back to you up, and you can have it in Java land, right? And that is another means of doing it, which, you know, I'm not presenting here because it's not a cloud, it's not out of scope for this. Does that answer your question, Talik? Maybe. Okay. We could talk about that a lot more after. So now that I'm back in my code, if we remember, if there are no other questions, we actually have a little issue here with just to keep something. And if I go into my code, you know, my Java code here, I will look at what's happening in my method and go, oh, I'm actually updating something at every iteration, and I'm allocating something new. And if I go look at what this just to keep something is, I will come up here and go, here's my constructor. And for some reason, the person who wrote this, who is me, decided actually I was holding an element, which was calculated pi, but I'm holding an array of 64,000 elements, and I'm just using one element. And there's no reason for me to be actually doing this, just for an example. And so imagine that I have a reason for having this holder, and I'm not going to actually say I don't, but I just want to say, hey, let me update this element. And again, I can imagine cases where you have this, your API trying to allocate, you know, a buffer, and you want to use that buffer. So in this case, imagine I just say, well, you know, I'm just going to update the element like this. And then in this case, I will have here my system. And then in my code, instead of just saying update some holder, which was here, I will do something smart and say, well, if some holder is equal to null, then that means I don't yet have it. So at that point, I will just do a some holder equals new just to keep something. And then I will, for example, use the element. I will imagine this no longer takes directly the object itself, but actually takes the value. Sorry. I told you this was a live demo, so we'll see if I do this right. And then here I will just say update, what did I call it? I think I called it update holder, update element, lm, and I just update it. So I only allocate it once. I say, please do that. And then I come down to my code and say, actually, I don't want you to always allocate it. I just want you to do that and just update it and basically get rid of this element, right? And say, please do that. And because I want to be smart, and because I'm testing this, what I want to do is change my version to 44. By the way, I was 42 because of the meaning of life, right? But when I was testing this, I think I got to 10 to make sure that I had something fun to present. So let's do that. Let's hopefully hope that it is installing and deploying, right? So I'll build it. Of course, I make a mistake in front of everybody. So I get to line 266. It is unhappy with me. And if it's unhappy in line 266, it is because I forgot a bracket. So let's go see my new method. This should be fine. Let's see. Where are you unhappy with me? These are the lonely moments of presenting something. Pi approximation, update some holder here, and then here, update some element. Let me see. Definition of insanity to just restart 266. All right, let's see. This is fine. This is fine. This is fine. This is fine. And this is fine. Okay. Let's see. Did I miss it? Right. Sorry, now I have to find where my compilation problem is. Let me look. Let's go here. If someone sees it, let me know. Huh. I am befuddled. Let's see. Where is my semicolon or accolade missing? Cache contains. I do here. Here I do uphold. Here we go. Just keep. Update element. Here. I have got no idea why you're not happy with me. Let me see. Sorry. Live demo, everybody. I apologize. Let's see. Do you work? Yay. Okay. That worked. Then I don't know what I did wrong here, but let's see. Let's see. Update holder. Here I'm going to do double LM. There we go. Okay, I'm not crazy. Live demos do not. Okay, so let's go here and then say, here we go, and then do here some holder equals null, and then do this, and then do that. Otherwise, let's do else and do some holder update element, LM. Okay, and then let's rebuild and just go, I don't know what happened. And I don't know what happened. Okay, so, and then let me double check that I changed my version so that at least we can see that things are working well. 44, therefore I can deploy it. And while I deploy it, I can actually just double check. So I say if it's null, otherwise just update and move on. And this does update some holder and let's go, right? So in theory, we should be fine. Sorry about the lonely moment. So let me show. And when this finishes, I will show you just where the agent lives. Like I said, it lives in /opt cprof because that's where the documentation says to put it. So that's where I put it. On this instance, I was relatively simple. And so give it just 2 seconds to start. There we go. And so if you look here, it should be, I don't remember where it is. Anyway, sorry. So if we look at now here, if I call perf, it won't, I can do start again to really get it started. I can come back here, right? And I can see that we are going for a whooping like 13,000 and that things are just gonna start like flying through there as all our numbers come in. And so if we now look at like here and we have to wait until our new version comes online, But theoretically, we've solved both problems, which is we've cached all our data because the profiler said that we were spending time there and let's optimize it. And then we figured out, oh, there's a problem with memory. Let me actually go and try to solve that. And that actually freed up the whole JVM so that it doesn't spend so much time doing allocation and GC measurements, right? And so all we need to do now is wait until versions come online of my new version. Are there any questions while we wait for profiles to start showing up?
Yeah, there is a question about from Ming that asks, I use Java profiler for optimizing Java methods running time. Is there any tuning that I can mark method that are running too long, more than a certain threshold? Try to only select.
So there's no, that's a good question. There's no good mechanism to like automatically mark those methods that you know of beforehand. You have the filters here that will allow you to say, show me everything that is like, if I already have this, I can say, focus on this one, and it'll show you how long this is running. But there's no mechanism right now to automatically help you filter out automatically those methods. You would really need to go into the cloud agent and add that code directly in, which is totally possible, right? And you can you basically can email either the cloud profiler people or even me and say, hey, I wanted to hack this together to see this, how would it work? It's just a question of like, it's not done automatically, right? Like we don't surface in these filters a mechanism for you to actually do that automatically, if that makes sense. Does that answer your question, Ming?
Yes. In the chat, he said yes.
Yeah, I was in the QA. I was like, oh, it's not moving. And so, okay, so ask expert version 4 comes up. And so now if I look at it, so there are a couple of interesting things that happen is that once we solve these two problems that we had, our code shows up on the left, which means if it's here, it's what's the most predominant of what I'm doing, right? And if you look at it, what we're doing is we're spending most of our time in the cached getPy method. We are spending a little bit of time getting the next request, which is a random generator that generally goes down into atomic long to do that. And we're spending a little bit of time doing the update some holder. But this is where we would expect us to be spending our time because that's where our code is actually spinning on. If I look at the heap now, we will notice that I still have my just to keep something. That's fine because now I know about it. But in theory, I'm no longer spinning on it and allocating like crazy. It just is allocated once and is there. Same as my cache. My cache has been allocated and will grow at a certain size. But because I know that my input is relatively bounded, it's not going to go crazy. And then if I start looking at the wall time, I also notice that GC has disappeared. It's actually all the way back here, which means that again, from a where am I spending my time, even including wait times, is actually on my PyCalculator run, right? And so that is really kind of like in my little experience of like playing around with optimizing code for Java. And I actually mean that. I work on the op profiler, less on optimizing the code, is where you want to be. You want to be in a state where you are not automatically spinning on GC, where your CPU time says I am spending a bunch of my time here on code that I know about and less on like the libjvm or libc or whatnot, right? That is generally what you would want for a Java job, right? I believe that is from a high level what I had as a kind of presentation and demo because I was trying to keep my code simple. But depending on what we want to do, we can talk about anything and everything. I'm happy to continue hacking in Java and showing you that I can create bugs and undo it and try again.
There is a new question from Fabien. Can you see the difference between two versions? Having an ID if you trial and error is having an ID if you trial and error is working.
So you can so see, like you can do ask the expert 34, let me compare to the version, compare to the version 3. And the way it shows you things, for example, from a wall time point of view, it says, see how this is like different. This is 9 seconds now versus 242 seconds. So you've reduced by 232 seconds of profiles for the GC and wall time. If you go look at the CPU time, you can go see and say, oh, I went to 100 milliseconds for my libjvm versus 1 second.81. And so I can see that optimization that I've got compared to that, right? And same way for like the thread run and all of these. So you can compare your versions. The only thing that you need to do is do what I was doing probably relatively very quickly, which is change the version ID as you create a new version and use that as your comparator. Otherwise, I believe that you can compare depending on end date, start date, zones, you know, whatever you want. Does that answer your question?
Yeah.
Awesome. And I drink a lot of tea. I try to stay awake because my 3-year-old and 5-year-old wake me up at 4 or 5 in the morning every morning. Any other questions?
Yeah, I have a question because I found this very special or magic because you have a lot of data on your job and you have a UI to view this data and so on. But there's a lot of data generated by your Java app, and there is a lot of Java app running on Google Cloud and App Engine and so on. Do you know where are stored all this data? If the data stay a long time in the profiler, where are stored the data, in fact?
Okay, so I'm trying to just ensure that I understand the question. Are you asking where are these profiles that I'm showing here stored once they're shown to the user, or as they are getting collected, where are they stored before they show up in the UI?
Both, in fact, both.
Both questions. Okay, great. So I will answer. I'll answer quickly on the latter one, which is when they're stored on this UI. I actually have no idea how Cloud does it and how long they store it. I would imagine that somewhere there's a means to wipe them all out. Like, I do not know. It's not what, like I said, under the hood, I don't know. However, how are these generated? I can explain, which is the CPU and wall time are done differently than the heap. So I'll start with those two. They are done in a sense of every so often, and it depends on how the continuous profiling system is handled. The continuous profiler, so this UI and what's the system underneath, will go and say, hey, job, go upload a profile to our servers. And if you go into, I can find it, you actually normally have a flag that says, I want you to do it ever so often, right? And so what it does, it says, oh, it's time for me to give a CPU profile to my user. Cool. Well, for my job, I'm going to go and wait 10 seconds. And I'm going to, every X amount of milliseconds, pick up a profile, bundle it all together for 10 seconds, and send it off to this UI, right? Well, the backend that's storing this. Heap profiling doesn't work that way. Because heap profiling, we want to know what allocations are actually still live and what does it represent for your whole job. Heap allocation is actually enabled from the beginning to the end and is not you can just turn it off and on because you want to know, hey, you just allocated a gig of memory. I'd like to see that. That's where I'm spending my time or my memory. And so in that case, the way it works is that it samples your allocations. And so it used to be 512K. I think it's every 2 meg now. Every 512 kilobytes, it'll say that object that just got allocated, sample it. And it'll show up as, if I remove this, it'll then show up as, hey, new node allocated something that hit that threshold. Here's a profile for it. And then it'll wait 512K more to do the next one, right? And so that lives in your job continuously, but because it's sampled at 512K, it doesn't use that much memory overall. And it's not just because I did this and I know the intricate details, it is not exactly 512K. It's actually a geometric mean around 512K so that you don't hit the same object if you were to do always the same allocation pattern, if that makes sense. So sometimes you'll do it at 200,000K, sometimes you'll do it at 700,000K. And so that is always allocated with your job at the moment. And so when the system says, hey, I'd like to get the heap profile, it just goes to its internal data storage and goes, give me what you got. And it'll just copy over what it's got into a profile format. Does that answer that question? Way too much details, probably.
Yeah,
under the hood?
Yeah, but there's a lot of question, or a lot of data exchange, or to oversee what's happened in the CPU or in the heap and so on. If there is
Yes.
not too much impact on the performance in the code.
So we've worked very hard on making this as low overhead as possible. So the CPU and the wall time have a low overhead. I will be lying if I told you exactly what the percentage is, but it's not huge. And especially it's not that impactful because it's on a point request. So it's not like your job always gets hit by it. It's more like, oh, I want a profile now. Okay, I might get slowed down for 10 seconds, but then I'll be fine afterwards. And I'm getting these profiles, right? But it's not massive slowdown. It just is, oh, you got a little hit. The heap profiler, internally, the version that we had was roughly about 2% overhead of your overall job. And the new version here that uses the JDK 11.1 is on par to that one. So from what we have measured internally, and don't quote me on the percentage and whatnot, but again, it's seemingly shouldn't hurt you that bad because it's that low overhead. And of course, this is optional because you have to add it to it. So theoretically, it doesn't hurt. Inside Google, we like to have this data. So we've enabled it for a decade, and it's been there for a decade on pretty much all our jobs. And so it's something that we just do, and we have this data available, if that makes sense. So the sampling technique for heap keeps the low overhead. The profiler itself also is a very low overhead because, like I said, the way it does things is that it takes a profile, stores it, and puts it aside, and does this really quickly, right? So it should not slow down your job that badly. And if it does, you can send me an email and complain about it, and I'd be curious to see why, especially the heap one.
Okay. Okay. Great. There is a bunch of new questions. The first one, how does the GNI interface work? What is the frequency of the profiling, data pooling? Does the Java agent do? And how does the continuous profiling work technically?
All right.
Can you share your Vim-RC?
Okay, and then let me look. Okay, so we did the Fabien Bonella. Okay, so lots of questions here in one question.
Yeah.
How does the JNI, so the way it currently works in this particular one, oh, we lost a big question. No, I was trying to find all the answers, all the questions. Anyway, the way it works here is the JNI layer, that .so that you get from the cloud profile that you can download. So the one that is given, if I look to, this is the YourKit one. I don't remember where is the cloud profiler. Let me see. Anyway, so the .so, the cloud agent that you can get profiling Java applications here. Sorry. So this one, this .so that you would get here, the profile Java agent, the way it works and the way Java makes its magic is that there's a magic method that's called onVMinit or agent load. And so when Java gets started, and when a Java job gets started and you have passed in agent path here, it calls your method in that .so and says, hey, I'm starting, what do you want to do on your side? When this code comes in, and if you go look at the code, and I can dig deep if we have a minute and we want to, it'll say start the heap profiler and the heap sampler, the heap sampler system that is from Jvmti. Start the loop that will go and actually go say, hey, every minute or so, go get a CPU profiler and go do all of that. And so it creates what's called an agent thread that will run alongside your program to upload those profiles to our UI, right? And so there's nothing that I do in my vimrc that I've got or whatnot that will actually tell it to do it. It really starts off with having that .so linked up as dash agent path and having this .so with a specific method that the JVM knows about that it'll deal sim to and say, hey, agent, what do you want me to do now? I started, right? And that's what allows us, for example, to detect if you're running in JDK 11 or JDK 8 or stuff like that, and determine what kind of things you want. Did I answer? There were lots of questions in that one. Did I answer all of them or not? I might have missed a few. It's run, well, a thread is in the process, right? So it is run in the process, right? It's just run in what we call native code. So it's not in Java code. So it's just run underneath, right? I have a tendency to imagine Java land up here and the native land down here. Right? No, it's embedded into your process so that you can see what the system is doing. Guillaume, do you want to go to the next? Do you want me to? I'll let you tell the question that way.
Yeah. Next question is this profiler related to visual VM in any manner? Profiling locally before going in the cloud is a good idea?
So visual VM, it's not. Visual VM is a side. It uses probably the same kind of infrastructure of like the agent and loading an agent and getting information about what the JDK does. So let me take a sidetrack and go, here is, so all of these systems that will profile Java jobs use what's called the Java Virtual Machine Interface. And all of these, what this interface is a bunch of how do you do it when the agent starts up? How do I go look at the code? What are the various things that I can look at? Memory management, what my threads are doing, what the heap is doing, what are objects happening, what are the like various locks that you've got, what are the timers, heap monitoring, the one I did in JDK 11, right? And so all of these various profilers will be using Jvmti to introspect and understand what your Java job is doing. Now, so it's related in the sense that most likely it uses parts of this, and it'll use ways of like introspecting into it. I always thought that visual VM was a way that you could actually connect on your local machine to understand what a server was doing, running a JVM, and it would give you information. But it would still most likely use an agent underneath on its side and send you data back. But I don't know that much about visual VM. Profiling locally versus cloud, it will always be an interesting question because it depends on your job. If your job is if you have a good workload that simulates what your job is doing in cloud, yay, profiling locally would be really cool to do. If not, you might be profiling the wrong things, and you might be on your local version seeing things that your profile is popping up that never happen when you actually run it in cloud. And so often it's a bit of both would be the answer that I would give in my mind, is like yes, understand what your code is doing, but also understand what it's doing under the load that you expect it to do. We have a tendency to say for optimizing, which is only optimize the code that's hot and keep the rest of the code readable. So yeah, does that answer that question? Or those questions, I guess? Maybe. Hopefully.
Maybe. I hope.
I finished my tea, so now I'll drink water.
Yes, there's another question about other languages. And do you know if there is a profiler, this kind of profiler for other languages, for Node.js, for example?
I do. So now I'm sorry, because somewhere we actually have like what is available for each language in a nice table. But here is for Go, for Java, for Node, for Python. And so these are all the languages that, all languages, these are the ones that have like profiling available. But I believe that like somewhere, like I said, we have a nice array. Go actually has the most little details about what your threads are doing and whatnot. I can try to find the table, but yes, Node is available, Python, Java, and Go.
Yeah, I'm sure you can also run, for example, Ruby code with Jruby. I'm sure because you execute Ruby code on JVM, you can have profiler for your Ruby code at the end.
Yep, exactly. As long as your job starts with the Java command, you can always pass -agent to it, and you can always see what it's doing under the hood. The interesting cases that we have at Google sometimes is your Java job runs a lot of native C++ code. Now, how do you profile that? Because you're not going to catch that in your agent. And so you might not see that because that C++ is not generating bytecode that then is run in JVM. And so in those cases, you have to provide other solutions for profiling what we call the native side of your application, right? Side story, but yeah.
Yeah, so at the end, that means that when you package your code with, for example, GraalVM to have a native image of your Java application, this agent doesn't work.
I have not. So no. So Graal, right? You're talking about Graal.
Yeah, Graal. Yeah.
So Graal is an interesting world and it's an interesting problem, but actually, the whole idea of Graal is that you still are. The agent is still, I believe, called with Graal, and you will still get a partial information about what's going on. Graal, I believe parts might work, but I'm not sure. Because I think that Graal still tries to respect the JVM conventions. The hard part about it is how do the stacks look when you're getting the profile. I would believe that in Graal we still call the agent and we still go initialize it. I would just be curious about what happens when you get the stack trace and try to symbolize it for a Graal system. In most cases, there are solutions, but I don't know. I don't even think we can run Graal right now in cloud, Google Cloud, right? I mean, if you package it yourself, yes.
Yes, if you package it in a container, you can run it where in your you want.
I'd be curious to see if that works. I do not know, but I'd imagine that symbolizer is going to fall down. Right? I would imagine that would be the problem because the way that we do the symbolizing is that we call a method that says give us all the stack traces and we walk the stack. And normally we are able with the JVM to say, hey, what is the stack that you're using? And I'm pretty sure that might break. The heap sampler though uses the version from the JVM itself to give us a stack as opposed to the CPU one. So it is possible that Graal has a handshake that says, of the stacks that are Java stacks, I must respect it and therefore work. But again, I do not know. But I would imagine that Graal does not break that link with Jvmti, but I don't know.
Yeah, interesting. I think we have we have to test this for having a clear answer. So
Yeah.
a new question here. Does production profiling a good idea? Does profiler keep the history for a long time?
That is a great question. I wish I knew that answer. So production profiling, is it a good idea or not? We have the various library or profiler engineers inside of Google at least have always advocated that yes, more data is better, and we've provided solutions for low overhead profiling, and we do it for generally all of our internal jobs. Have profiling on by default, and these kind of systems on by default. Um, the 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 thing about having profiling on your production jobs, if you're able to do it with low overhead and double check that it is with low overhead and what is it acceptable overhead even with this agent on, is that when things run awry or when you have a problem, you can go into the server and go look at where are you spending your time, where are you stuck, what's the wall time, am I stuck in GC right now, what am I allocating, was there this weird thing that was on there that I can see that you can have on the fly with a job in production. Whereas if you don't do profiling in production jobs, you're kind of blind when jobs go wrong, and that is something that we have, at least I have seen in the past, where users will come complain about a job and we'll go, hey, can we go look at the profiles? Show me what's going on. So do I think it's a good idea? Yes. Do I think that it's something to be done lightly and just turn it on and don't look back? No. Pay attention to, what's happening to your job when you turn it on, see what happens and decide for yourself. But it is something to consider because it gives you, I believe, a lot of information about what your jobs are doing. Right? Hopefully that. And this is JC's opinion, who does not do any app engine, who does not do jobs in production really, right? But just from what I've seen when users come see us. Does that answer your question?
Yes.
Cool.
Yeah, cool. A new question that I didn't understand, so it's my lack of understanding of Java. Can we plug into the JIT compiler with Jvmti?
So is the question, can you understand what the JIT compiler is doing via Jvmti? Okay. Then the answer is yes. You actually have a lot of information with Jvmti for the compiler, such as, let's see if I can find it. Oops. Where is it? I thought it was just because it's idiotic. So you have information of like, is this method synthetic? And you have something like, I just compiled this method. And so it's like compile load, or let me look for unload. I think it's unload. And so you have a bunch of information about this method has been loaded. This is what is happening in your method. You can see what methods have been compiled by the JIT. You can get you can actually get the generated code, and you can see what kind of generated code it did. You can understand if it was compiled by C1 or C2, which are the two JIT compilers that are generally there. I wish I could find the entry points to it, and I will if I just look at it. But generally, yes, you can see a bunch of things. You can't see everything, but you can see quite a lot about what the compiler is doing and what it's not doing. I wish I could just find where it was. I'll find it if I keep thinking about it. I will look at it. Does that answer your question? So yes, I just wish I could find where it does it. I thought it was on compiler load, but maybe not. It might be is anyway. This would be me pondering about the Jvmti. Does that answer your question about the compiler though? And I can look a little bit more. But yes, if you look into this documentation, you'll find the spots. And we have historically we used it at some point when we were looking at what code we were generating for various methods, right? And so that is generally what we have used it for. And like I said, it's very useful for that. Here we go. Here, man, all I have to do is talk about it. Compiled method load and compiled method unload. And you also have other random ones which are like method entry, method exit that you can call. Those will add quite a bit of overhead. Compile load and compile unload will add overhead as you're compiling, but not that bad. The thing that also is interesting is you can actually get it to, you can get the Jvmti system to tell you all events that it would have generated if the events were on. And so you can at one point in time go, give me all the methods that you would have compiled. And it'll just give you all those methods instead of having it on all the time. So you take one hit in the middle of your job, for example, just to see that, if that makes sense. I know I'm very low level compared to like higher level questions. Sorry.
Yeah, I have a higher level question because you can deploy and package your code where you want. You can deploy on App Engine as you did. You also show that you can use the profiler on Compute Engine and other system. And I'm wondering if the packaging tool, I mean, if you package your application in App Engine or in a Docker container and you deploy it on Kubernetes, on Cloud Run or elsewhere, is the impact or the profiler is different according with your packaging method that you use, or even the JVM versions that you use, or the JVM builder or provider?
So, wait, let me, I'm not trying to understand the question, but I'll try to answer in the sense of, as long as when the system is unpackaging it, it tells you know where that .so is and you can pass it as a command line flag to start the job, then you would be able to load up the agent regardless of the packaging system, right?
Yeah.
And then the second part is, if you don't know what JDK you are running, or not automatically which one you're running, the way the Jvmti system works is that it actually provides you with a nice method called getEnvironment. And here it is, where when the agent loads, you can call this method, because that's the way it works. The agent load has a Java VM pointer, and you can say, for this VM, I would like to get this version of Jvmti. So for example, JDK 11, and it'll say no if you're running in JDK 8. Or it'll say, yep, here's a Jvmti, you're good to go, you can go do your fun. And so that is the mechanism that you can have a single agent code running in different JDKs, is that you can use this method to detect which JVM is running, what is the environment, what is it doing. I'm not trying to answer your question, but
yeah, but it's great. It's great. It's a good answer. But exactly, my question was, is it possible to have some difference of performance? For example, you perform a profiling with App Engine because the code is packaged automatically by Google Cloud, okay, and it's deployed on App Engine. And then I would like to package the code by myself, and I install OpenJDK 11, of course, but it's not exactly the same JVM runtime as Google Cloud. Can I expect the same profiling, or the profiling can be different because the JVM, the native code is different?
Yes, you would expect a different behavior. You should expect a potentially different behavior. Not massively, probably, but I would say the JVM of all worlds in life, Java is really an interesting beast because a lot of decisions are made out of heuristics and whatnots that are hard to understand exactly why it's happening. When does GC get triggered? How does that impact your job? So imagine that, for example, on one version, you are just on the curb of what would have started the GC. And in the other JVM version, you are just above that threshold. On the first one, you wouldn't have had GC happen at all in the critical moment of your code. And in the second one, you have GC happening just at that moment, right? And now your behavior is totally different, and you have a bad experience in one JDK and a good one in the other one. And those are the kind of things that can happen. Do they often happen? I mean, I would say yes, but critically happen? Probably not. But there are minute differences that can just happen from one JDK to the other. And it can be as small as you had this library that was added, and is in one packaging compared to another, and that just shifted a little bit yourself versus a percentage, right? Or it loaded differently, and so for some reason the counters are off on the various method entry counts, and so it compiled methods in different order than what it would have in one different run, and now your behavior is different. So do I believe that from one run to another in the same environment, your performance can be different? Yes. Can you tune your jobs in a way that things become stable and predictable? Yes. Does it require a lot of work? Heck yes.
I
Right.
guess.
But I don't think I'm surprising anybody in that, like saying, in every job, regardless of the language, if you want to fine tune machine, you kind of need to spend some time understanding what's happening. Right. It is kind of like as soon as you start looking at performance, you start seeing, oh, why is this happening? Oh, right. Does that answer your question?
Yeah, it answers the question, and it's difficult to predict what's happened when you switch from one environment to another one. But the profiler, I understand that the profiler is a good way to find the bottleneck in your code. And if you want
Yeah,
to fine tune, it's tricky, but to find the bottleneck, it's a good tool for this.
exactly. Yes.
Yeah, there's a new question from Andres. Can you tell us a little bit more about the most common problem or optimization that you have found using Profiler in Java?
Huh. That I have seen. So the one we've seen that comes up from time to time is really memory being held by hash maps that people forget that they're holding and that do not clear at the right moment. And for example, so if you have a bunch of requests and you have a hash map and it's just running and you never think about clearing it, you just have this memory that's always there and is always never going to get garbage collected because that hash map is always available. And so that is one thing that we've seen from time to time of like, oh, this is happening. The other one is the other side of the spectrum, which is a job that is generating a lot of small objects. And because it's generating a lot of small object, it kicks off GC, which takes time. And this is better in JDK 11 than it was in JDK 8 because of the new GC system, which is called G1, I believe. I'm not a GC expert by any means, but those two spectrums were what we used our profiler a lot because we're able to see, oh, you're allocating a lot of like value of why. And then we would go into code and go, oh, because you're doing this packaging and this boxing. Okay, well, can we do something differently? Or, you have this weird like cache here, but it should be gone by now. There's no reason this is still here and using a gig of memory or 2 gigs of memory. And because this is there and using 2 gig of memory, now my GC is running more often because it's got less space before it starts kicking off GC. And so it's keeps on hitting. And so I would say those are the most commonly ones that we've seen from a heap point of view. And then from a CPU point of view, often it's been like GC is running, and we did not expect GC to run that much. And so what's going on, and how can we tune and tweak the Java flags to make GC play nicer? How can we optimize the fact that like in our timeline, GC doesn't do that much work during the critical moments of our server, kind of things. Does that answer your question? I know it's high level, but I don't have I don't have technical examples I can show, so those are the ones that come to mind. Okay, yes. Awesome.
Perfect. Yeah, new question. Do you ever read resources from the top of your head, excuse me, about JVM flags, tweaks, and how to use them?
I would be wrong to give any examples of flags to use. I believe that so let me start with the biggest caveat, which is any optimization should be done very carefully with the right profiler and right data to show that what you're doing is optimizing your code in enough of a way that is worth the burden of keeping those flags up to date. Every time you add a flag, you now have to like go, is that flag still right or wrong? And people forget about these flags and leave them for years and never know why they were up to this point. And had they put no flags, the JVM caught up and is better than with those flags. That being said, the flags that will play around with really performance is any flag that will touch your compiler. So are you running in the various JIT compilers, C1, C2? Those will affect your performance. And so little history of how Java works. You have your bytecode, and your bytecode is run via an interpreter. And at some point, if you run the same method X amount of time, the compiler thread comes around and goes, this method has been running in the interpreter for too many times. I am going to go compile it to generate a native version of it, which is more optimal. And it'll go do that. And then when you call back that method, it'll go into that optimized version. Once an optimized version is run enough times, it's considered hot enough to get recompiled again into what's called the optimizing compiler, or C2, right? And so then you have this optimal version that is running even faster. Now, you have various flags that will allow you to say, don't try to compile, or we'll say, compile only with the optimizing one and skip over the one in the middle, or don't compile for the optimizing one. Now, depending on your job, people might go, why would you want to do that? So the examples are, if you know you have a very fast running job or request, you might never want to compile it because there's no point in having to compile to do things. If you know that like you are in various moments of like, you don't want to go into the middle ground, you go there. In the GC world, it's the amount of memory you want and what you want to tell the GC to do that will change your performance, and that will depend highly on your job. So anything that's playing around with maximum memory, low memory, how play with the GC are going to be flags that will change your behavior. Do I think that you should use them lightly? Again, I'll say no, do not use any flags lightly. Do it knowingly of what you're trying to accomplish, and remember that these are maintenance burdens that you will carry over for a long time. Can they help? Yes, they can. So I know I'm not answered the question on purpose, but like, hopefully I said, yes, there are flags that you can use. I don't automatically think that there are ones, there are none that are great or bad, just as what you're looking to do. It's profiling your code and understanding what's going on, and then looking at what could you do to help. What we have seen in the Java world, and I'm guessing I'm not, again, what we've seen that helps for Java is what's called heating up the system. And like just ensuring that, for example, you know that your job uses this request a lot. Well, before starting to service users, call that request a X number of times to ensure that it gets compiled. And therefore, on the first user request, it gets a compiled version of the execution code so that it's stable. Those are things that help. So it's not a flag itself. It's more, how do you bring up a job in Java? Again, I do not think hopefully I answered ish. Low level Java, I know, I'm sorry. And I'll drink water.
Yeah, I wasn't aware about this compilation by the JVM to optimize the code. I didn't know this just before you talked about this. That means if I run my code at the beginning, it could be slow, and over the time, it could be better and better.
Yep,
And of
that
course,
is
and the profiler can change also at the beginning and after few requests, not few requests, with after a lot of requests, it could be changed in the time.
so exactly. And so the interesting parts is that there are also a fair amount of heuristics that will check if your code has changed its behavior. And uh, there aren't that many things that are done. Like it will really have to trigger out a lot of things to like recompile it, but it can recompile things. And so there are various things that you can do also to force those kind of cases. But often it's got enough heuristics to try to like get it in a good stable state. The JVM is what's called hotspot, which is the runtime of Java. It's been done for 20 years and it's pretty optimal. Like it's very smart people have been working on it for 20 years. But yeah, it does start an interpreter, which is slow. It compiles it to a middle form that has still profiling inputs of like, where are you going in the code path? What are you calling me with? What are you doing? And that will get sent out to another compiler with information about that code so that it can optimize it even better. And so the cases that are interesting is we talk about null pointers all the time in Java because if you have a null pointer, it generates an exception. Null pointers are often implemented in a way where it is it's handled by the system. And so you will actually do a segfault, but the system catches the segfault and goes, oh, I did a segfault in my code. Oh no. And if you do enough of those segfaults in your compiled method, it'll say, oh, this method is doing a lot of segfaults. Okay, let me actually explicitly do an if that is equal to null, because clearly your case uses that. Otherwise, it's an implicit nothing is null in Java is how things are compiled, except proven otherwise. And so when I say segfault, it doesn't segfault for the user, but the system goes, oh, it's segfaulted, if that makes sense. Again, very low level information, but I know. Cool.
Yeah, I have a question for you because there's no new question. I didn't catch at the beginning if you are working for Google or for Google Cloud, but I think what you are doing is for both parts of the world because
So interestingly enough, I used to, when I joined Google in 2016, I worked on the Java agent, which is our internal version of what this is called the cloud profile agent. And we provide Googlers with other profiling information, other things that their Java jobs are doing and whatnot that we think that, whatnot, I don't know what's happening today with my whatnots. Anyway, and then 2 years ago, I moved away from the Java team, right? And I went to go do something totally different, which was profiling our user requests. So, for example, if you come into a code, like for example, the code I was showing, if it ever will reload, when you do that do get, how long does that take? But especially because latencies are different, maybe 1 out of 1 million requests is going to be much slower. And that is a request you want to know about because that's your problematic request. And so sample the requests and only surface up to the user the profiles of the long ones, right? And so I worked up for that for a year. And then I got an email saying, do you want to work on code health in Atlanta? And I said, okay, yeah, I'll go do that. And so I moved to Atlanta, which is now you're in a basement in a house in Atlanta. And I work on code health, which is automatic change around Google. So Google, we have a repository with more than 1 billion lines of code, and we often want to migrate code from A to B. And how do you do that automatically? And how do you get your code tested? How do you find a reviewer? How do you submit it? Long story. But because I was working on the Java agent for 2+ years, I still do a bunch of cleaning and maintaining of that code because it's my background. And so I'm presenting today because I know this code and I know the Java agent, but I actually have not been actively working in the Java ecosystem for a year and a half, 2 years, right? It just is that I am the one who open sourced a heap sampler for Java. And so I get asked questions about the profiling systems generally.
Okay,
Right?
interesting. Yeah.
Yeah.
And I have a very difficult question for you.
Uh-oh.
Is Java the best language in the world?
So I spend a lot of my time helping people prepare for interviews and interviewing at Google and doing things. And my answer will be the same as I give people who are interviewing, which is each language has a reason that it was created and a reason that it works well. And depending on what you are attempting to achieve, that language might be the right one or the wrong one. Therefore, is Java the best language for everything? No. Is it good for a lot of things? Yeah. Right. Do I personally prefer Java to another language? It depends on the day. Sometimes Java infuriates me. Sometimes Java makes me very happy. Right. So hopefully that's a good answer.
Yeah, good answer. Yeah. Yeah. So there is no new question from the attendees. Maybe it's late in France and maybe some are
It is
sleeping.
late, right?
Yeah. So I have no new question on my side. I don't know if Jean-François have someone. I have some.
Otherwise, it's just you and me.
Yeah, exactly.
No, I don't have any new question. I think that there was lots of question, very deep, very high level. So no, I won't add anything else. I think. Okay. I think we have finished. Thank you very much, Jean-Christophe. It was a very huge session and very high-level session. So
You're welcome.
thank you
Very low
again.
level, I know.
Yeah, as I say, it was what we were expecting. So
That's good.
and where I heard all the question, and indeed, it's not questions that I could ask myself, but I easily understand how precise they were, and it's a sign of a good topic because when you have a precise question, it's that the topic interests people. So.
Yeah.
Okay, so if people are too shy, I propose to everyone 5 or 10 minutes again in the room, in a private room, if you want. And I think we can stop now. Thank you again. Bye bye.
Thank you very much, all. Have a great day or evening.
Goodbye.
Bye.
Bye.